Okay, hello everyone. I think we're live now. So the topic for today, live stream, the other day there was a tweet of a person asking about how to deploy Datadog in K3s. And I decided to give it a try. I hadn't used before K3s, but I wanted to try it out for a while. So I thought that this was a very good opportunity to do so. So let's share my screen here, hopefully bigger. Okay, that's better. So what is K3s? So K3s, a little bit word game. It's small or lightweight Kubernetes. So some of you know that the way to short Kubernetes is K8s because there are 8 letters between the K and the S. So that's easy to pronounce. You just say Kubernetes, even if you write it K8s. With K3s, I don't think there is a word. It's just 3, I guess, is smaller than 8. That's the name. So I guess that's just called K3s. So basically what it is, it's, as they said on their website, it's an open source project by Rancher. It's lightweight Kubernetes. And one of the things that it says here is that it's a certified Kubernetes distribution. What does that mean, that it's certified? So the CNCF, the foundation that it's behind Kubernetes and other projects, has this conformance tests, there is a GitHub project here, that for every version of Kubernetes, you can run your distribution of Kubernetes, you can run this set of tests, and basically if those pass, you can, well, there is some paperwork involved as well, but you can basically claim that that you're real Kubernetes for whatever the version. So we can see here, let's find, yeah, K3s is here because they've run the test. They have here their results and how to reproduce them. So if someone in the CNCF want to double check, they can do that. I haven't checked a lot about the test, but it seems like from browsing a little bit on these results, seems to be more tests related to the Kubernetes API. So they make sure that basically you can do the same things that you can do in any other Kubernetes distribution. So that's good. So now we know that K3s is one of these distros that pass these tests. And why it's lightweight? One of the things that they do, and this is very interesting because it's very easy to get up and running very quickly, is that all the different processes that you need to run Kubernetes are distributed in a single binary. So you just have to download single binary and install that. So to try this, so what I'm going to do, let's check quickly. So first of all, let's see a little bit how it works. So they have what they call K3s server, which is basically more or less what we understand in Kubernetes, like the control plane. So the thing that running the API server, the Kubernetes scheduler, the controller manager, etc. And then you have the K3s agent, that it's basically what we call in Kubernetes a node. Basically, you need to have a kubelet to run your containers. In this case, they're using containerd for the runtime, but basically it's that what we call a node. So to try this, the best way is to have 2 different machines. So that's what we are going to do. And the way we are going to do this, I'm running Mac here. So I need to run this on a VM. And I'm going to use Vagrant for that. So let's have a look at my Vagrant file. So basically what I'm doing here, it's super simple. The only thing that I'm going to do here is to spin up a couple of VMs with Ubuntu 18.04. And one, I'm going to call it the control plane, and one I'm going to call it the node, so I know where am I. And what I'm going to set up is a private network between those two machines, because obviously they have to be able to communicate with one another to one be the control plane, so the Kubernetes API server, and the other one be the node. So let's do that with Vagrant up. And it's going to take a little while. So it's going to create that. While this is creating, let's have a look at what do we need to do to deploy this. So the first thing it says is that you have to download the binary. As I said, this is a single binary for everything. And they have releases for AMD 64, but also for ARM. Let's open this page, which obviously it's a GitHub page. And we have a set of binaries. This is the AMD 64 by default. This is the ARM one. As you can see, more or less the size of those binaries are more or less the same, about 50 megabytes, which is very good, pretty small. Let's see how this is going. Still setting up. Okay, we are done. So let's go back to the page and see. So the first thing that you need to do is to download this and run a server and then run the agent elsewhere. So first thing that we are going to do is SSH into what we have called the control plane and deploy the server there. So let's do that. Let's clean this up. So let's SSH into our control plane. Okay, here we are. So as I said, this is Ubuntu 18.04. Just clean default Vagrant image. Let's copy the binary address. Let's download that. Let's make sure that we can execute that, and let's move it to someplace in our path. So we make sure that we can find it. Okay, that's fine. So if we follow the instructions, we should just do sudo K3s server, and that's it. But when I was playing with it, I got a little bit of issues. And the reason why, and I'm going to explain this in a second, the CNI, so the network layer that K3s uses, it's Flannel. And Flannel, what it does, so maybe you don't know, but Kubernetes doesn't implement pod networking by itself. So you need to use a plugin, and there are many plugins out there to try. And this one uses Flannel. And Flannel, what it does, this is a diagram that I created for a different talk. This is more or less how it works. So Flannel, what it does is it's going to create an overlay network. So in this case, in this example would be the one that I'm putting here, 10.244.00.16, which basically means, and then it will give an IP to any pod on that network. But the way Flannel knows how to route the traffic, they maintain a table, basically, to know exactly what that pod, what part of the network, the subnet, it's on every host. And then Flannel will redirect the traffic to the right, to to the right interface. But the thing is that when we are using K3s in virtual machines, if you do if config, you can see that there is many, well, in this case, 3 different network interfaces. So if we just run this, Flannel will try to redirect traffic from one host to the other using this first interface, and that's not the interface that we have on our private network. It's this second one. So if you don't tell K3s what is the interface that connects every host with one another, you may have trouble when everything may seem to be working correctly and pods inside the same node will be able to talk to each other correctly. But as soon as one pod needs to talk to a pod in a different host or to the external traffic, like Datadog, for example, you will start having issues. So there is a command to that, that of course I can remember, but let's copy this and let's, well, first of all, let's copy this so I don't have to. And the it's Flannel something. So let's see where it is. Flannel interface. So in this, with this parameter, we can tell it to Flannel what is the interface that is going to connect all the hosts together. So let's do that. And let's copy the interface, which we have it here. And instead of running on the background, I'm going to run it in the foreground so we can have access to all the logs. So this is the server that is going to be running. And at some point, let's see, yeah, here, it took the IP for the interface that we wanted to have, so that's gonna work fine. And we're running Kubernetes 1.17, so pretty up to date. 1.18 was just released, so it's normally it takes a while. Okay, let's go back here. And then let's check this instead of just having kubectl and have kubeconfig set up, they do that through the same binary, K3s. So what we're going to do to stop, to don't have to type all these things all the time, we are going to create an alias. First, I'm going to set into the control plane again. Yes, we are not on the right folder. Okay, so let's create an alias here. I'm going to create also K because that way I type less. And let's see. Cool, we have our control plane node running 1.17, all good. So now we are going to to have a different machine acting as a node, as a worker node, and we are going to add it to this particular cluster. So how would you do that? So going back to these instructions, which as you can see are very small, easy to follow. Basically it says you have to run the same binary, but with a different command. It's an agent pointing to the server IP or DNS if you have name resolution. and a token to be able to connect to that server. And that token is going to come from the server, and it's here. So let's try to get that. So we are here on the control plane. So we are going to get that. So we have it here to do. And what we are going to do that now is we are going to SSH into the, again, we are not on the right folder, so that won't work. SSH into the node. And obviously we need to do the same thing. We need to download the binary, same binary. So there is a single binary for everything. Then we are going to give it permissions. We are going to move this to some place in our path. And we check that everything is working fine. So let's create let's put the token here so we can copy and paste the same command that that they had. And then we have to run the agent with the IP of the server, which we are going to retrieve in a second. But same thing. So this is exactly the same thing. So Flannel is going to run on every single node, and every node needs to know what is the interface, the network interface that to route traffic from one node to the other. So we will need to use basically the same Flannel interface parameter. So first of all, let's check the IP of the, this is the IP for the main interface that we are using for the server. So that's where it's going to go. Let's copy the command. Let's copy the IP. Let's put the default Kubernetes API port, and then the token. And then let's help here because, again, I can't remember the name of this Flannel interface. And we are going to check, this is the name of the interface, again, that we will be using to connect to the control plane. So this was Flannel interface, and then Flannel interface. Let's do that and see if it works. So at that point, it's going to run the agent, and it's going to try to connect to the Kubernetes API that we have in the control plane node. And obviously, you can see that it's creating some IP tables rules to redirect traffic for the services in Kubernetes and creating the subnet and everything. So if we do here again, the nodes, we are going to see that now we have two nodes. We have the control plane one, and we have just a working node here, both running 117, which seems to be, and both in the ready status, which seems to be the reason that everything is going fine. So what we are going to do now is we are going to deploy, now that we have our cluster up and running with two nodes, we are going to deploy Datadog in it. So just looking at the instructions, the documentation that we have in Datadog, We are going to deploy this just with a manifest. So first of all, we need to create cluster role, service account, cluster role bindings. So we are just going to trust this, and we are going just to create all of this. So now we have a service account that is going to run a Datadog pod, Datadog agent pod, and all the permissions to the Kubernetes API. The next thing, we need to obviously create a secret to make sure, let's make this bigger, create a secret to be able to send data to our Datadog account. I'm going to do that elsewhere. So I'm going to do this outside the window that you're seeing to avoid putting in public my API. It's a demo account, but anyways, I don't want people to start sending stuff there. So this is what I'm going to now. Okay, this is done. So if we go back to here and we say get secrets, we can see that I have created now the secret here that has my API key to connect to Datadog. Cool. Last, we need to basically create the Datadog agent manifest. There are several options depending on what you want to be enabled. So you have a manifest with everything, logs, APM, process metrics, and depending on what you want, it's there for you. Obviously, you can edit it yourself, but this way it's a little bit easy. So let's download this one, the one that has everything. Why not? And if we check quickly this one, it's running the latest version of the agent. It has some ports open for APM. So you can see it's using the same Datadog secret that I created for my API key and some other options. Okay, so let's apply that and see if it's going to work. Let's clear this so it's a little bit more. You can see this is something interesting. Let's do wide. It's creating two containers. So a daemon set in Kubernetes, it's basically one pod or X number of pods, depending on the amount that you're requesting, X number of pods on every single host that you have. In many Kubernetes distributions, the control plane nodes are tainted, so that when you create a pod or when you create a daemon set, by default, it's not going to add a pod to the control plane nodes, basically to make sure that the control plane nodes only work for things like the controller manager, the scheduler, etc. In this case, this is not the case because we have created a daemon set and it has created one pod per node, one for the control plane and one for the node. This means that basically if you want to use K3s, but you want the control plane to be just for the stuff for the control plane, you will need to add those things yourself. But it also means that if you want to try out K3s and you don't want to have two different nodes, you just want to have the one because you're trying something quickly, you don't need more than one node, just spinning up the server is going to be enough because you're going to be able to schedule pods there. So we have both running. Let's check the agent status to see on one of those. Okay, so we have some logs here, and we have also some checks already running. So it seems to be working fine. Let's see here. The host map for cluster. And here we have two nodes, the one called the control plane, the one called node. And actually, if we go to containers, we are also able to see the different containers that we have per node. So in the control plane, we have these ones, and this one on the node. We should, the reason why we are not seeing one of the containers, obviously, that we are missing here is the Datadog agent. This is actually an option so if we check again this file, we have tell it here to exclude the Datadog agent. So if you want to also see the Datadog agent containers as part of your infrastructure, you can remove this option and it will show up. I think this is good for our first introduction of K3s, what it is, what can do for you, how to deploy Datadog, making sure that all the networking in Flannel works well, so we can basically send traffic to Datadog and between one host to another. And that's it for today. Thank you. Thanks for watching.